Welcome to Vinex IAS Academy. Today you are going to learn how to do multiplication using Nikhilam method, okay, using subbases. Okay. Now basically Nikhilam method, the main basis, the numbers needed to 10, 100, 1000 and so on. Okay. And coming to the subbase, the numbers which are multiplied or divided into the main base and resulting numbers would be the subbases like 20, 40 or whatever it might be, 500, 200, so on. Let's take one, the basic method. This we will discuss later after doing with examples. Okay. Let's take one example. Suppose if you want to multiply 42 and 47. Now 42 and 47 are the numbers nearer to 40 or 50. So here we can take a subbase as 40 or 50. When you take subbase 40, 40 is nothing but 10 into 4, which is, so main base is 10 and subbase is what? 40. Now 42 is 2 more than 40 and 47 is 7 more than 40. So our right part is nothing but product of 2 into 7. And the left part we have to take diagonal. Either we can take 42 plus 7 or we can take 47 plus 2. So 42 plus 7 will give you 49. Then and 2 into 7 could give you 14. Later, whatever operation is performed to get subbase, the same should be applied to the left part. Now subbase is what? 10 into 4 we have done. So here you have to do 49 into 4. Now 49 into 4 will be 196. Now since our main base is 10, we have to maintain only one digit on the right side. So 4 will be taken here and 1 will be carried. Now 196 plus 1 will give you 197. So our final answer is 1974. Okay. So let us see again. Our main base is 10. 10 into 4 equals to 40 is our subbase. Now 42 is 2 more than 40. 47 is 7 more than 40. So right part is 2 into 7. Left part you can take diagonally 42 plus 7 or 47 plus 2. Now note here, whatever operation is performed to obtain subbase, the same should be done to the left part. Here we have done 10 into 4 to get 40. So this into 4 should be reflecting here. So 49 into 4 will be our left part. So 190, that is nothing but 196. Right part is 40. Since our main base is 10, we have to maintain one digit on the right side. So 4 will be taken down and 1 will be carried to the left part. So 196 plus 1 will give you 197. So 1974 is our final answer. Let's take the subbase 50. Since 42 is nearer to 50, we can take subbase 50 also. 50 is nothing but 10 into 5. Now when you compare with 50, 42 is 8 less, 47 is 3 less. So our right part is 8 3 are 24. And left part, as usual, you have to do any one diagonal operation, either 42 minus 3 or 47 minus 8. Both will give you 39. Next, whatever operation is done on the left part or to obtain subbase, the same should be done on the left part. Now sub base is obtained by multiplying 5 to the main base. So left part is 39 into 5, which is 195. Okay, and right part is 24. Since our main base is 10, what you should do? Maintain one digit on the right side and remaining 2 will be carried. Now 195 plus 2 is 197. So our final answer is 1974. The same we can do, that now 50 can be obtained in two ways. 10 into 5 or 100 by 2. Let us see what is the operations when you go with 100 by 2. Now again when you compare 42 with 50, it is 8 less and 47 is 3 less. So left part is diagonal subtraction, 42 minus 3, and right part is 8 3 are 24. Okay. Now to obtain 50, what you have done? 100 by 2. So here what you have to do? 39 by 2. 39 by 2 is 19.5 and our right part is 24. Okay. Now we can't have a decimal numbers. When you get decimal numbers on the left part, decimal numbers of fractions, what we need to do? Multiply that fraction part with the main base 100 and shift it to the right. So 0.5 into 100 should be shifted to right and left part will be 19. Now 0.5 into 100 is nothing but 50. 50 plus 24 will give you 74. So our final answer is 1974. Okay. So is it clear? Let's take another example. Suppose if you want to multiply 253 into 257. Now here 253 and 257 are nearer to 250. So our sub base should be 250. Now 250 is what? 1000 by 4. 1000 by 4. So our main base is 1000 and sub base is 250. So sub base is 250 and main base is 1000. Let's see how to get it done. Now 253 is 3 more than 250. So deviations are plus 3 and plus 7. So our right part is nothing but 3 into 7. Left part what you have to do? Cross, add or subtract. So it is more, you have to add. So 253 plus 7 will be our left part. And right part is 3 into 7, 21. Now 253 plus 7 is what? 260. Now, what are the operations we did for getting sub base? Divided main base by 4. The same we have to do here. 260 by 4 we have to do. So 260 by 4 is nothing but 65 is our left part and right part is 21. Okay. Okay. The operation there. Now, do we have to prefix what we have to do? Since our main base is 1000, so we have to maintain 3 digits on the right side. So our left part is 0 to 1. Okay. So our final answer is 6521. Okay. So is it clear? Let's have another example. So let's see what are the main operations we use to get it done. We have to adjust the left part according to the sub bases. Okay. So if sub base, if main base is 100, we have to maintain 2 digits on the right side and so on. Okay. So this is our final procedure. Let's see again. Left part, we have to cross or add or subtract. Adjust left part according to the sub base. whatever operation is used to obtain subbase from the main base must also be applied to the left part. If subbase is main base into n, multiply left part by n. If subbase is main base divided by n, divide left part by n. Okay. So if any fraction part, then multiply it by main base and add it to the right part. Right part, what you have to do? Adjust the right part according to the main base. If right part has, if our main base is 10 power n, we have to maintain n digits on the right side and remaining should be carried to the leftmost. Okay. So this is our final procedure. Let's take some more examples how to get multiply using subbases. Suppose if you want to multiply 62 into 65. Now 62 and 65 both are nearer to 60. Now 60 is nothing but 10 into 6. So here main base will be 10 and sub base will be 60. Now 62 into 65. This is 2 more than 60. This is 5 more than 60. Now what is our left part and right part? Okay. Now left part 62 plus 5. You have to do diagonal operation. Right part is 2 into 5. So this will be 10. This will be 67. Now subbase is obtained by multiplying 6 to the main base. So we have to multiply 67 into 6 on the left part. Now 67 into 6 will be how much? 6 is 36. 60 into 6 will be 360 and 7 into 6 will be 42, which is 402, and right part is 10. Since our main base is 10, we have to maintain only one digit on the right side and remaining should be carried. So 1 will be carried here. Our answer will be 4030. Let's have another example, say 53 into 46. Now these numbers are nearer to 50. So better we can take 50 as a main base. 50 is nothing but 10 into 5. Now 53 is 3 more, 46 is 4 less. So this is minus and this is plus. Okay. Now our left part is 53 minus 4. Right part is 3 into minus 4. Now 3 into minus 4 is what? Minus 12. This is 49. Our main subbase is obtained by multiplying by 5. So our left part will be 49 into 5, which is 245. And left part is minus 12. Now minus 12 can't be our digits. So what we have to do? We have to take one carry from here and then we have to convert into positive. And here minus 1 will be carried here, minus 2 will be here. Minus 1 when you take carry it will be 244 and this is say minus 2. Minus 2 again can be converted by taking one carry from the left part. So answer will be 243. 10 minus 2 will be 8. So our final answer is 2438. Okay. So let's take some more examples. If you want to multiply say 195 into 197. Now 195 and 197 are nearer to 100. So near to 200. 200 is nothing but 100 into 2. Okay. Now Our left part will be 195 and 197. This is what? 5 less, this is 3 less. So left part 195 minus 3 and right part will be 5 into 3. This is nothing but 192 and this is 15. Now our subbase is obtained by multiplying by 2. So multiply 2 on the left part. So our left part will be 192 into 2, which is 384. Okay. And right part is 50. Since our main base is 100, so you can have 2 digits on the right side. So no change is required for the right side. So our final answer will be 38415.